Hello, 7th grade. This is lesson 4. Objective for today is how do you use the number line and work with sequences. First of all, let's talk about a number line real quick. Number line consists of the origin, which is the point 0, and all the positive numbers, which are to the right. So like 1, 2, 3, 4, 5, 6, 7, 8, etc. And all the negatives to the left, which is negative 1, negative 2, negative 3, negative 4. Now notice, each of these numbers has a corresponding number, what we call the opposite number. So like 3 has the opposite negative 3. And they're both the same distance from the origin. So distance is not necessarily to scale, but if you were to measure a real number line from here to here, or from here to here, then it would be the same distance from 0. So as you move further right, these numbers get bigger or greater. So 7 is going to be bigger than 3. As you move left, these numbers get smaller. So 3 is going to be smaller than 4, 5, or 7. Likewise, still these numbers over here, so negative 7 is going to be smaller than negative 4. Kind of think about which one you'd rather have. Would you rather owe someone $7, or would you rather owe someone $4? I would rather owe them $4. I'd rather not owe them anything at all, but if I had to owe them something, I'd rather owe them 4. These are negative numbers, positive numbers, and 0 is not positive or negative, it's just 0. So this is like example 1. It says arrange from least to greatest. So we have the number 4, negative 1, negative 3, and 0. So if we're going to list these from least to greatest, I'm going to look and see which one's the furthest left on the number line. That's going to be the least, the least one. It's going to be the smallest one. So this one I see furthest to the left is going to be negative 3. Then as I move right, I notice that negative 1, so it's going to be my next one. So it's that one, that's that one. And then as I'm moving, oh, there's the 0. And then I'm going to come up here, and there's the 4. So those are ordered from least to greatest. This is like example 2, it just says compare. So I know I'm going to be using one of these symbols. That one's bigger, this is greater than. Or this one, less than. To compare which one is bigger or smaller. So again, here I'm going to find number 4, it's over here, and negative 7 is over here. Since 4 is further right on the number line, I am going to say 4 is greater than negative 7. Now to look at this one, notice negative 3 is here, negative 4 is here. Since negative 4 is further left, that means it's going to be smaller than negative 3. So again, I'm going to say negative 3 is greater than that negative 4. Alright, this is like examples 3 through 5. It says add or subtract on the number line. So here's what we're going to do is we're going to say, here's number 4, so I'm going to, well, I guess you always start at 0, and then you're going to go to the right to 4, because it's a positive number. And then it says plus 2. So I'm going to start at this point, and I'm going to go to the right 1, 2 more. So that corresponds to the 6. So I could say this is equal to 6. Okay, but since it says add or subtract on the number line, I'm going to be showing this operation on the number line. Okay, so I'm going to go 4, so I'm starting right here at 0. I'm going to go to the right 4. And then because it says minus 2, that means I'm going to move to the left. So I'm going to start here and move to the left 2. Notice I get 2. So this 4 minus 2 is equal to 2. Now this one, similar to the one before, but not quite the same. I'm going to start at 0. Move to the right 2. And then I'm going to move to the left 4. One, two, three, 4 spaces. So notice my final answer there is going to be negative 2. So as you can see from this example, 4 minus 2 is 2, and 2 minus 4 is negative 2, which means those are not commutative, alright, which we already learned in our last lesson. That subtraction is not commutative, meaning you can't switch their order and still get the same number. However, you will notice that their numbers are opposites. The numbers are opposites. This one is equal to 2, this one's equal to negative 2. So these numbers are opposites of each other. So we can use that to solve problems like in number 6. This one says 219, well, it's going to be way out this way, minus 430, which is, notice if I just look at 430 versus 219, this one is bigger. So no matter, kind of like over here, where I moved right, but this number is bigger, so it means I'm going to end up with a negative number, because this one is bigger. I'm subtracting a bigger number than from a smaller number. So what I'm going to do is I'm going to apply or use the things that I already know how to solve. I'm going to say 430 minus 219. Now notice that's not what the problem says. It says 219 minus 430, but I know that the answer will just be the opposite of what I'm doing. So I'm going to have to borrow from here. It's going to be a 2. So 10 minus 9 is 1. 2 minus 1 is 1. 4 minus 2 is 2. So I want to say my answer is 211, but I know it's the opposite of 211. So my answer is going to be negative 211. Alright, now let's learn about sequences. A sequence is an ordered list, and I'm going to go and highlight that ordered, is an ordered list of terms that follow a certain pattern. Whenever I say ordered, that simply means that there's a first one and a second one and a third one. And then terms are just kind of each of those numbers between the commas. Okay? I gave 4 different examples of some sequences. Okay? And these follow a certain pattern or rule. So for this one, it's just the evens, a set of all the even numbers, even whole numbers. So it's 0, 2, 4, 6, 8. So they follow that pattern. Right? You can kind of find the next one based on the next pattern. So if I ask you, what's the next one? You'd say, oh, you would say 10, 12, 14. This one's the odds. So 1, 3, 5, 7, 9. The next one would be 11, 13, 15, etc. You can kind of see that pattern in there. Now these two are examples of arithmetic sequences. Yes, it looks like arithmetic and spelled the same as arithmetic, but this time we say it arithmetic sequence. Arithmetic sequence means that you add the same number each time to get the next number. So notice, from here to here, I added 2. From here to here, I said plus 2. From here to here, I said plus 2. From here to here, I said plus 2. Actually, it's the same thing here, I just started a different place. From here to here is plus 2. Here is plus 2. They could be something different, maybe like 5, 10, 15, 20, where I add 5 each time. But notice on this that those are equally spaced on a number line, right? If we were to color these in on a number line, it'd be all of them would be evenly spaced apart. Now look at a couple others. If I look at multiples of 3, maybe I should have started at like 0. So there's 0, then there's 3, and 3 times 3 is 9. 9 times 3 is 27. This is what we call a geometric sequence because I'm multiplying by the same number each time. So from here to here, I probably shouldn't have started at 0, just kidding. So from here to here, I'm multiplying by 3. From here to here, I'm multiplying by 3. From here to here, I'm multiplying by 3. So if I want to find the next one, I need to take 81 and multiply by 3, which would be a big number, so we're not going to do that right now, but you get the basic idea. Same thing here. This is multiples of 5, so 5 times 5 gives me 25. 25 times 5 gives me 125. If I took 125 and multiplied it by 5, I get 625. And again, if I want to find the next one, I just multiply by 5. Again, a really big number. So this one is multiplying by a number each time. And this is what we call a geometric sequence. Now notice, a geometric sequence is not equally spaced on a number line. So if you see a sequence on a number line that's not equally spaced, then you would know that it is not arithmetic. Now, it is possible for it to not be arithmetic or geometric. It could be neither one. So just know that they're not all arithmetic or geometric. You could have neither. Okay? This is example 5. It says, find the next terms of the given sequence. So notice here it goes 1, 5, 9, 16. I need to fill in these blanks. What's that? What's that? What's that? The next 3 terms. So I need to try to find a pattern. So the first thing I want to do is maybe it's arithmetic, meaning they have the same number. So I'm thinking, what do I have to add to 1 to get 4? Well, I say that would be plus 3. But if I add 4 plus 3, I'd get 7, not 9. So I know it's not arithmetic. So let's see, 4 plus what gives me 9? Well, 4 plus 5. It's 3. And let's see, 9 plus what would give me 16? Well, 9 plus 7 would give me 16. Well, I'm starting to see a pattern because I recognize these numbers. 3, 5, 9. Those are examples of odd numbers. So I'm going to see if I can continue that pattern on. So to get from here to this next number, I'm going to have to add, what's the next odd number after 7? 9. Let's see, 16 plus 9. I'm going to write that over here. It's going to be 15, so 25. And then the next number after that, next odd number after 9 is going to be 11. So I'm going to say 25 plus 11. It's going to be 36. Then to get the next one, I have to add 13, the next odd number. 36 plus 13. 49. Okay? So I found the next 3 numbers. There's also another way to find a pattern in here, and that might be, if you notice here, these are perfect squares. Like this first one is 1 times 1. This one is 2 times 2. This one is 3 times 3. This one is 4 times 4. So that means the next one would be 5 times 5, 6 times 6, 7 times 7. You can kind of see that pattern there as well. So if you had seen that one, you could have ended up with that one as well. It's like number 8. It says, the rule for a sequence is k is equal to 3n plus 1. Find the first 4 terms of the sequence. Well, the first 4 terms, notice here, this gives us a rule, right? It says the rule for the sequence is this. So k is going to be my terms, and n is going to be which. Remember, because it says the order. So what we need to do is we need to plug in numbers for n. We're going to plug in numbers for n. What we're going to do is we're going to plug in n is equal to 1, n is equal to 2, n is equal to 3, and n is equal to 4 because I want the first 4 terms. Okay? I'm going to see what that k is. So here we go. So k is equal to 3 times 1 plus 1. Well, 3 times 1 is 3 plus 1, so it's going to give me 4. This next k is going to be 3 times 2. Again, guess I'm plugging in 2 in for n. I'm going to add 1. 3 times 2 is 6, plus 1 is equal to 7. Here we go. K is going to equal to 3 times 3 now. Plus 1. Well, 3 times 3 is 9. Plus 1 is going to give me 10. And then I'm running out of color, so I'll go back to red. K is going to equal to 3 times 4 now. Plus 1. 3 times 4 is 12. Plus 1 is going to give me 13. So the first 4 terms of the sequence will be this. 4, 7, 10, 13, ... That'd be my answer. Now, if you haven't noticed your homework already, it starts on page 32. You're going to do all the 4s from lesson 4. all of the questions from lesson 3, and then 4 more of your choice. Good luck, guys.